Hi, everybody. Thanks for coming to my talk. Today we're going to talk about threat modeling machine learning-based features. Oop, nope, that's not the button. So my name's Jack Murphy. You may have seen me speak here before the pandemic under a different name. In classic pandemic fashion, I disappeared, did the trans thing, and came back. Hi. This slide is just to show that I don't identify with my job at all. I will still be happy to talk to you in the Slack about which teams have the best psychological safety at my job and real stuff about salaries, but I'm not here to pitch for any one tech company. So what is the inspiration for this talk? In tech as a field, we talk a lot about basically every job in some way, involving, learn to code, and you should be, automating stuff you're doing, or you should be, doing things with ML. But we suggest these things, and then as security practitioners and infrastructure and IT practitioners, we're not really enabling that as a system. And that's not to say that I don't care about what's going on in Salesforce or Oracle Cloud or your HR system. Just that is not what we're here to threat model today. Today, we're going to talk about how to threat model data scientists and their output. The why do we care slide. Basically, left unmitigated, attacks on ML systems can find their way into the physical world. Any scenario that can be twisted to psychologically or physically harm users is a catastrophic risk to your product or service. So what we're looking at here in the background is an IBM internal memo from 1979, famously. This clearly doesn't hold true today. So what you're looking at is logos of two companies that develop ML technology that has hurt people. So Equivent, if you have heard of the sentencing and parole software that is just blatantly racist and is trained off terrible data and is working in a terrible system, that is them. And then obviously Tesla, which has killed at least one driver and I believe some number of pedestrians. So these real world attacks are imprisoning and killing people, which may be true of some software malfunctions, but I think it is more uniquely true of machine learning. Okay, so I'm making some assumptions about who you are, and we're not going super deep because we have 25 minutes and this is a huge topic. So I put a bit.ly link for the main resource, but I'm going to drop a link in the chat so that you can look at these slides and click these links at the end. But I assume that you are a security professional who has to threat model, and you've got some developers you're threat modeling with who are using ML, but you personally don't really feel comfortable about the difference in what you're threat modeling with your other product engineers and with your machine learning engineers. So I'm just going to give you the framework for how to think about the problem based on how you're probably already doing some threat modeling. And then you will take these lists of questions from the resources with you to your threat model for your machine learning engineers to answer, to be clear. Okay, so where are we going? Quick review of what threat modeling is and the goals. And then we're going to talk about data provenance. We're going to hopefully take a bit of a mental break to talk about infrastructure threats, which should be, I hope, a little bit more familiar. And then what does it mean to attack a model? Anytime you build an app and you put something on the internet, people are going to try to attack it. But when that is a machine learning model, what is different about that? And then we're going to have a quick chat about training data. And then I will have a political complaint about negative externalities. Cool. So what is threat modeling? Basically, the goal of threat modeling as a practice is to determine the assets in the system and how we're going to protect them. And you sort of run it as a pre-mortem where you ask what would fail in a given system to identify what could go wrong, what the blast radius is if you don't protect things, and highlight and document your assumptions and risks. So the big brains at Microsoft Security gave us the acronym STRIDE as a mental tool for how to think about inversions of the things that we generally want to be true about our software systems. So you've heard of the CIA triad, right? So there's confidentiality, integrity, availability, and then we've got the extended authenticity, authorization, and non-repudiation. So in this particular talk, I will call out a few categories of this for ML specific stuff, but not too much for the infrastructure. Okay, so a core question that I don't think we ask enough and maybe isn't part of the standard STRIDE framework is if your software even works. We think of it as being available, but this is what integrity means. But in the case of machine learning, what is it that makes the model work? This might be familiar if anyone has read the O'Reilly book on machine learning, the quick intro. This was titled The Unreasonable Effectiveness of Data. And these are just like 4 very popular algorithms. And what this is telling you is basically the larger corpus of properly labeled data that you have, the less it actually matters what algorithm you're choosing to use. The data obviously also needs to be correctly sampled and unbiased, and these are sort of other considerations. But then the next question is, where are you getting this data? So essentially, the greatest security threat in machine learning today is data poisoning, because we don't have any standard detections and mitigations for poison data. And we tend to depend on untrusted or uncurated public data sets as sources of training data or user input. So if you want to avoid a garbage in, garbage out training cycle, then it's critical that you track the provenance and lineage of your data. However, it's also critical that you learn to detect anomalous and malicious data entries and be able to distinguish and recover from them, because it's inevitably going to happen. So essentially, in the same way that we assume breach when we're talking about our internal networks, you want to assume poisoning of the data that you're training from, which you could get from a data provider, or you could get from your users, depending on the input source. So here are a few questions that you can ask or that you can bring to your threat model. So essentially, when you assume that data is poisoned or tampered with, how would you know that? It's not clear that the telemetry they have is going to work. When you think about the Google SRE book and what they call the kind of golden indicators, those aren't necessarily going to be helpful in terms of tracking the performance of a machine learning model. One particular type of machine learning technique that is worth calling out especially is reinforcement learning, because it can essentially spin out of control really quickly if you're doing user supplied input. I believe this was the technology behind Microsoft's Tay. I did not include a screenshot, but essentially when you're dealing with user input, we're not just thinking about like SQL injections here, we're thinking about trolls. And this is basically how they got a chatbot that was supposed to be a friendly teenage girl to be a really terrible, an approximation of a terrible person in a couple of hours, because it was trained off of Twitter as people were tweeting at Tay. So when that happens, how do you recover from that? We think about doing like database backups, but are we thinking about backing up the model? Are you doing versioning? How, when you're doing versioning, are you tracking what training data went in there? Can you retrain? How do you keep this out? Yeah, and then kind of akin to the 4, or in this case, they don't apply, but the golden metrics. Like if you're monitoring some things now, but maybe that's not throwing an error, like, would you know that? Have you actually turned this monitoring into something that's useful? And then additionally, what's the impact of the model being inverted or the training data being recovered? There are some attacks that can lead to a model leaking the training data. And this can have many and varied consequences. We'll actually chat about those in a couple slides. Okay, this is hopefully the quick mental break, because I would assume that most folks here are more familiar with the idea of like vendor evaluation for third parties, or also talking about when you write code, what are the software dependencies? When you're talking about the infrastructure you run it on, what is happening? So in this case, obviously, there's still the data scientists I work with Python, so I'm sure this applies to R and everything else as well. But there are some very popular libraries like Pandas, PyTorch is even a package manager for popular libraries. And all of these could still suffer from the usual type of like buffer overrun or, other like malicious things that are both exploitable or could like poison their logic. Additionally, it's very common to start from a pre-trained model and then to modify it a little bit. And the source of the pre-trained models needs to be vetted just as much as the source of the data that we were talking about in the previous slide. So if you got this model from a model zoo, what is the source of that? Why do you trust that? Like, who built that? Could you get the source and build that yourself instead? And then the infrastructure, if you're hosting it yourself, obviously you need to make sure that you've got your standard suite of protections. If your Spark cluster is just on the internet and someone could just like unauthenticated change something in your model, this is obviously a big deal. But similarly, whatever platform you could be developing on would be a juicy target if they had a malicious insider or were otherwise attacked, that they could steal your model or they could backdoor your model so that it works in a way that you didn't intend. So you still need to do very thorough diligence on all of these technologies that they're using. Okay, I made this a bit.ly link in case anyone was screenshotting it, but like I said, I will include a link to the slide so you can get this at the end. I just don't want you to try to memorize all of these attacks or their mitigations. I want you to take this link with you with its list of questions to ask your developers, basically. Okay, so I did not put down here several unintended failures that all kind of come under a category that we wouldn't really call in stride, which would just be like compromising the safety of a system, which more or less comes down to if you did incomplete testing, like you trained something in a particular environment and then you put it in an unfamiliar environment, or you literally just didn't think to put enough categories of something in a training set, then you put it in the real world and it could behave in ways you don't intend. And if that's, a car that's looking for light to reflect a certain way, the safety of everybody involved is obviously at risk. So for the rest of this is more assuming that you've got something like an API that is exposing a model and you've got users like interacting with this model in some way. So essentially perturbation attacks, these kind of break down to tampering. I put the stride model here. Tampering can be basically poisoning the data, which can be at different phases of training. And as I mentioned, can get more out of control more quickly if you're relying on reinforcement learning. You can, membership inference generally is brought up as a big deal with sort of protected class information or medical information that can be a big deal. There are ways to attack certain models where if a user is allowed to just throw as much information as they want, as many queries as they want in it, you can look for spikes in confidence that indicate that something was a member of the training set, and that could essentially leak further information about that person if there were more information about what the training set were. Reprogramming deep neural nets. This is sort of similar to the reinforcement learning, the same idea of with untrusted user input. If they know a bit about what training technique is being used, there are particular kinds of ways that you can modify your input data to make the model give you a false positive or a false negative, or to just completely change the behavior of the model if it's changing itself as it goes. We mentioned sort of as part of the machine learning supply chain, that would be like a malicious machine learning provider, the software dependencies, sneaking in some like backdoor machine learning on that platform. All of those are, problems for the integrity, as well as disclosing information about the model, if it could be taken just from the platform, or for some models, if it can be queried enough and in very particular ways, you can invert and steal the model. Sorry, we already did membership inference and model stealing. Cool. I think we've got all of these. Okay, so the punchline for a lot of these, when you are talking about a model that is going to have to be robust to adversarial inputs in the real world, you want to do adversarial training. This is not something I can give you a ton of guidance on because this is an emerging academic field. So that's why I recommend Robust Bench. I probably should have put a screenshot in here. They are a collection of implementations of different types of adversarial training with links to the original source paper. And then there is kind of a standard suite of adversarial software to attack models. So what they're doing is running that in an automated fashion and ranking how robust various models plus adversarial training mitigations are together. So this will extremely depend on what you're doing at your company. But along with your list of questions that you're taking from Microsoft, which are way more than I have in here, you also should take your list of mitigations, which is going to be this robust bench. And this is my moment of getting on my little soapbox. So there are a lot of ethicists who are calling out very interesting things right now, and it's certainly important to care about bias in the data or our framework right now for a lot of things that are like GDPR, how we think about machine learning, talk about the data subject. So it's a lot more about if you got a model to leak my information or you inferred that I was a member of the training set, then it can be said that I have been wronged in a legal sense, right? Like I could sue a company. But if I were, not part of a training set and somehow I get equivent, like I am in a courtroom and equivent software is used to like deny me parole or set my bail very high, I wouldn't be said in a legal sense to have standing, even though that affects my life. So I won't send you down any specific rabbit hole here other than Salome Viljoen's work. But it's worth thinking about what the ethicists are saying in this field as you're also reading proposed regulation from GDPR, which I do recommend you do. Actually, the Irish data regulator has some really like nuanced and thoughtful guidance on data handling, as it were, which is what we're going to finish up with here. So you've probably already got, if you're at a large enough company that they have a security team and someone who's threat modeling stuff with them, you've probably got a data classification and handling policy. So the model itself is potentially intellectual property. This is not normally how we think of our code executing when we put it on the internet. You would care more about like your GitHub. But in this particular case, as we've discussed, just making it available through an API can still leak some of these things. So as you're doing your threat modeling, consider that in your classification of the model. Consider also, as we've talked about, that a model can be tricked into leaking information about its training set. So in a sense, its classification can also be the sum of all of its training data and whether or not it's intellectual property. And then I did not have time to do a run through here, but if you have any familiarity with machine learning as a process and or you've read the O'Reilly book or done Google's run through, then the elephant in the room is that data requires cleaning and tagging. And you can't really do that if you're not looking at it on your laptop and manipulating it, which, is potentially against your existing data classification and handling policy if your security team isn't aware that that's what's going on and how machine learning developers have to work with things. So yeah, a quick note on anonymization versus pseudonymization and re-identification risk. Anonymization is possible. It's getting harder as more and more information is revealed online because those become attack data sets that you can then essentially join with anything else you find. You can do certain substitutions of like recognized named entities, but this is not always useful depending on what software you're trying to write. You need to talk about this with your data scientists. So frequently they will use instead something called pseudonymization. So this does have like a legal definition in GDPR. So the data subject, when you pseudonymize something, you take out the direct identifier. So the only possible identification path is indirect or needing to be joined with another data set. it is within the framework of GDPR, it is within guidance that you can have that other data set, but you need internal controls on how to separate that. And you need to have all of kind of the standard things that you think of with GDPR. So you would have to have like good logging and monitoring of who is accessing these things and who's potentially joining them. I did want to point out re-identification risk. There are several ways to measure this, but it more or less comes down to the concept of, even if you can't be directly identified by certain things, if there are enough demographics left over, such as like age, gender, and zip code, that can still be used to identify exactly or almost identify someone as one of like a small handful of people. This is, there are many ways to handle this. I in a naive approach in one company was able to get them to drop this data, but that can potentially skew your data. A sort of emerging thing that I have seen recently is synthetic data generation. So again, this depends on what your set is and what you're doing to begin with, but there are methods that you can read papers for to take the existing sensitive data, and essentially if you could pull that in one area and sort of ETL and move it over where the process is, you just generate synthetic data based on it that gives you the same statistical properties that your developers could still work with, and you put that somewhere that they can interact with, then what they have on their laptop doesn't really matter because it's not really anybody's data. Full disclosure, I have not done this, so I'm not really sure that this will work without you doing the normalization and cleaning step. But this is, in my opinion, probably the most robust that you're going to get. Yeah, and this is the list of resources. Again, the big brains at Microsoft are the ones that have all the questions. That's the very first link. That YouTube video I linked is someone who has worked on Robust Bench, who goes into a lot more detail about different kinds of adversarial training that have worked out well for certain things, such as the fast gradient sign method and pruning different neural net connections. I did throw something in there, assuming that we are in an Amazon-based world, of how you can safely deploy SageMaker with all of the infrastructure guarantees that you would want. That is the Irish data protection guidance on anonymization versus pseudonymization. And then those are my political takes at the end. Wow, I think I've got about 2.5 minutes to answer any questions in the chat if anyone had anything they wanted to ask. The bit.ly, yeah, I'm sorry. I can in fact post this whole thing in the bigger chat. I think the resources you'd recommend, how to exploit and remediate them. This is, okay, a lot of these are really emerging. So it will come down to reading a lot of papers and trying to decide if they work for your team. So where is Robust Bench? So on Robust Bench, they have, wow, I'm sorry, I cannot find it. They have all of the papers that describe the methodology of what the attack was on what algorithms and what the adversarial training methods that they're working with. Are there any templates to describe threat modeling? Yes, also within Microsoft, they have a great Stride template because they are the ones that invented it. Practical to get people to look at ML data manually. Yeah, so normally it's like a sampling thing and you're looking for things that go wrong. And I'm blanking on the name of the Apache project that does help people like label and clean things. But other methods I have seen are that people essentially contract that out to, I think Crowdflower was like the Mechanical Turk equivalent, and they will have folks tag and clean their data that way, which sounds like its own kind of privacy and third-party nightmare. Sorry, and Uma, cleaning data. In this case, I think the term I probably should have stuck to is normalized, which just means if you're taking all of these fields and you're like training on it, then you don't want any like outlier in a field that is going to throw off your model or that was like improperly formatted. This is especially if you have user supplied inputs, like a bigger risk. Thank you, Mickey. Thank you for the robust bench link. Cool. Well, if that's my time, I guess I will see all of y'all in the chat. Thanks for coming on this incredibly fast tour of machine learning with me.